Hi, so I put all the answers to page 5 right here on the wall, and I want to go through it real fast. And I'm going to move over here and get out of the way. Um, Page 5 says the upward force of a body when it is submerged in a fluid is called the buoyant force. The relationship of force was discovered by the ancient Greek scientist Archimedes, and the principle is named after him. The force is dependent upon gravity, the density uh, of the fluid, and the volume of the object submerged. Um, the mass of the submerged object doesn't matter or doesn't play a part in determining this force. The principle also explains why ice floats at the top of your drink. Um, Submerged objects with the same weight as that of the fluid displaced have neutral buoyancy, and one practical application of this principle is the construction of submarines, right? So they make submarines that way, which use water pumps to move water in and out of chambers to change its average density so that it will rise or sink. And the same principle is used with a swim bladder in a fish, allowing them to move up or down in the water. So that's the big idea. And I've put stars next to the ideas that I like. I like the swim bladder in a fish. We want to make sure that when we're talking about buoyancy, we're not talking about weight in the water. We're talking about the forces in the water and whether something has if there's enough buoyant force to make something rise up, or if it's more dense than the water, then it's going to sink. And so those are the things. Just the idea of using Archimedes' principle to its full extent. So now I'm going to move on to the true-false section at the bottom at the bottom of page 5, and I want you to remember, really and truly, the only one I like as a true-false question, maybe, is this Bernoulli's principle of number 5. I do like the idea of number 1, but you should always know this. There is no time when there's no kinetic energy or movement inside a particle. So the particles in a crystal lattice do not move at all. That's definitely false. There's always some sort of kinetic energy, always some sort of movement. Number 2, butter and glass are indeed examples of amorphous solids. They don't form a crystalline lattice, and you can shape them any old way you want. Now, glass, when it's cooled, of course, is pretty rigid, but you heat it up and you move it. It's just like butter, only butter you can heat up pretty quick and move it around. Number 3, when most substances freeze, the particles move closer together. Obviously, that's true. Water is most dense at freezing? No, that is not true. Water is most dense just before freezing. They say 4 degrees Celsius, and it's just when it's getting close to that freezing point. I think at 3 degrees there are some particles in the water that begin to freeze or begin to form that crystalline lattice, and that starts to expand it out a little bit. Therefore, it's a little bit less dense. Increasing the pressure on water increases its freezing point, and that's false. Remember, we increase the pressure, right, and that slows down the water behind that pressure, but on the other side of that pressure, the velocity increases as the pressure decreases. Again, that garden hose idea, putting your thumb over it, creating more pressure behind, everything slows down, but as it comes out and takes off and goes much, much faster, it's released that pressure. Elasticity is the ability of a solid object to return to its original form is so true, right? That's still the idea of the spring or the rubber band. It wants to return to its original form. Uh, Ductility is the property of a solid that allows it to be hammered into sheets, and that's not really true. Um, and we're not going to touch that. We're going to move on to number 8. The symbol of the coefficient of linear expansion is indeed alpha, and beta, that big B thing, if you speak German, it's that double S is beta. The symbol is alpha, and that's true. Number 9, the change in length of a solid is proportional to the change in temperature. That is also true. And last but certainly not least, metals used in a bimetallic strip have the same rates of thermal expansion, and that's not true because different metals have different rates of expansion. And that's it for this page, and I'll do the last page shortly and upload them all at once. But really, Bernoulli and Archimedes are the guys that are kings of this page. And so if you know Bernoulli and Archimedes, you should be great.